How are we doing, everybody? Welcome to this lesson of online learning. So today we're looking at the indicator, solving systems of equations. We're going to be looking at this for like the next 2 days, I would say. Today we're going to be looking at solving by graphing, and then tomorrow we'll get into the other two methods, which are substitution and elimination. So with that said, we're just going to get right to it. I'm going to try to keep this video under 7 minutes. That's the goal. We'll see if we can do it. So, the first step for these is we're going to need to graph these. We're going to see that we're not in slope-intercept form. So that's going to be the first step we're going to do, is we're going to take them and we are going to get them in slope-intercept form. So for this first one, we have 3y equals negative 15 minus 2x. In order to do that, we just got to divide everything by 3. And when we do that, we are going to get y equals, we're going to go negative 2 thirds x minus 5. Let's double check that to make sure we're right. Good. All right, awesome. And the next one is similar. I gave us negative 3y again. So, or negative 3y. Last time we had positive 3y. So we're going to do the same thing. We're just going to divide by negative 3 to both sides. And when we do that, we are going to get y equals negative 8 thirds x plus 7. Double check it. Good. All right, perfect. So we're good. We have our two lines. And now we're going to graph them. Okay? So we're going to do this here. We're going to do one in each color. This one's going to be blue. And this one is going to stay green. So our first one's in green. So we're going to plot that y-intercept of negative 5. So it's right here. And then we have a slope of negative 2 thirds. So we're going to go up 2 and over 3. Up 1, 2, up 1, 2, 3. Right there. Up 1, 2, over 3. Right there. I'm going to make a couple points in the other direction. So we're going to go down 1, 2, and over 3. And then we are going to plot this line. Boom. There's our first line. You'll notice that I extended the line all the way out. That's super important for these because we're going to find that out in a couple minutes. Alright, so next up we have y, I'm going to change my color. Boom. We have y equals negative 8 thirds x plus 7. So we're going to graph the y-intercept and positive 7. Then we have negative 8 thirds. So we're going to go down 8 and over 3. So down 8 and over 3. And we're going to go down 8 and over 3. Okay. So, and from here, what we're going to do is we are going to graph this. Oh, I missed that second point, but you get the idea. So, we're going to see that there's a... hold on, bear with me. I broke my stylus, so this is my first day going without it, seeing how it goes. Alright, so we're going to see that there's a point right here, right? It doesn't quite look like it goes through, but I think that's our best bet to see where they go through, where they both go through. So let's just double check. From this green line, we get a slope of negative 2 thirds, so from the point negative 7, 3, negative 7, so this point right here, we go down 1, 2, and we go over 1, 2, 3. So that green line would also be at this point. So we're going to see that both our lines go through that point. That's super important because solving systems of equations, well, what that tells us is it tells us where our answer is. So it's going to have an answer of x is 1, 2, 3, 4, 5, 6, right? X is 6, and then y is negative 9. So let's write that down. So we found our answer of x equals 6 and y equals negative 9. Alright, so I guess I should have summarized systems of equations first. So what we're looking for with systems of equations, we're looking for the x's and y's that make both of the equations true. So once again, we're looking for the x's and the y's that make both of our equations true. Alright, so with that said, we think we found the y, the x and the y that make both of our equations true. What we're going to have to do now is we're going to have to double check it. Yes, we're double checking it. So, with that said, here we go. First one, we have negative 9 equals negative 2/3. That's a 3. We're just going to erase it. Negative 2/3. And x is 6 minus 5. Zoom in a little bit. And then we're going to see negative 2 times 3. This is going to be 6 over 1. So it's going to be negative 9 equals negative 12 over 3 minus 5. We're going to see that negative 9 equals negative 4 minus 5. And negative 4 minus 5 is negative 9 equals negative 9. So that first one works, which is great because it should work. And now we're going to check the second one just to double check to make sure. So we're going to go zooming in right here. I think that'll be enough space. X is 6, y equals 9. So we'll change color, keep it in blue. So we're going to get 9 equals negative 8/3 times 6. I think that, yeah, this should be a negative 9. 6 over 1. I'm just going to do it in fractions. Simplify a step, plus 7. Then we're going to get negative 9 equals negative 48/3 plus 7. And then we're going to get negative 9 equals negative 16 plus 7. And then guess what we're going to find? Negative 16 plus 7 gives us negative 9. So we're going to get negative 9 equals negative 9. And boom. We've double checked. We found that when we plug in x and y into both the equations, they both end up being true. So we know that when x equals 6, y equals 9 is our answer. Okay? When x equals 6 and y equals negative 9 will be our answer. So to summarize, for solving systems of equations by graphing, once you graph both lines, your answer is going to be the coordinate where the lines cross. So our coordinate here was x is 6 and y equals negative 9. The coordinate where the lines cross is your answer. And that was x equals 6 and y equals negative 9. So real quick, just to get us thinking about it, if the answer to the system is where the lines cross, when would we have no solutions or all solutions? Well, there's really only two cases if we think about it. What would happen if our lines are parallel, right? If we have two parallel lines, when would our lines cross? Well, never. So when we have parallel lines, we're going to have no solution. And then, for all solutions, well, when would we have two lines that cross on all the exact same points? Well, that's when we have two lines that are actually the same line, right? When we have two lines that are the same line, it's going to be all solutions. You're going to see those in examples that you're going to do a little later on, so just be mindful of those. That's going to do it for the day. As always, please send me a quick email if you have any questions. See if I'm under 6 minutes.